Hello, and today we're going to work with logarithms again. Today we're going to focus on two specific log bases. They're called common and natural, but just as a reminder, the exponential equation you may have worked with in the past, something like maybe y equals a to the x or ab to the x, can be rewritten as a logarithm shown below. And we're going to work with that today. If you recall, a to the 0 is 1, and if we wanted to rewrite this in log form, we'd recognize our base. Our argument is the outcome, so our input for log is the outcome or output of exponential, and so therefore the solution would be a 0. And that doesn't look quite as natural maybe as a to the 0 equals 1, but that's something to pay attention to. Likewise, since a to the n equals a to the n, not a lot of important information there, we should know that when we take a log base a of a to the n, we just get the exponent back. And then finally, a to the 1 equals a, therefore the log base a of a, we could put in a 1 if we wanted to. The solution is a 1. So the input of these exponents becomes the outputs of our logs. So something to get familiar with. We're going to work with two specific bases, in this case 10 and the number e. Log base 10 of x is just written log x, and then log base e of x is written ln of x. And from a computation standpoint, we can take the log base 10 of 5, and if you wanted to write that as an exponential, we'd be saying 10 to what power equals 5? And it turns out the answer is that irrational number. And it should make some sense that it's a number less than 1, because 10 to the 1 would get us too big. Likewise, if we used e, we'd see that, and this is a base e here, we could write log base e, but it comes up so much, and especially the sciences, that they just have their own term for that ln. We would say e to what power equals 5, and knowing that e is a number slightly bigger than 3, our answer should be slightly bigger, or somewhere between 1 and 2, and that's what it is. Here's a quick example of where 2.71828 ... comes from. As we look at interest in an account, we could say, we see that plugging in 1 or 2, 4, we increase to monthly here. These numbers keep increasing, and so it's possible to think it goes to infinity, but what happens is, as these numbers get really big, you're adding a really, we could say maybe infinitesimally small value, raising it to a really high exponent, and what happens is we get to some number. This isn't exactly it, but it's pretty close. If you look on a calculator what e is, it'll be a number that looks like that. So this number e is kind of an odd thing, but it really is useful, and we're going to work with it. So the log key that you'll find on your calculator right here, log, is log base 10, and the log key you see here, ln, is log base e, and they're so useful that they have their own key. If you look at the blue key above it, the blue key on this one, the second log, is a 10 to the x, and of course e to the x. And now if we want to use our calculator to find the log of 200 just to see what it looks like, we can take the log button, type in 200. What this is giving us is what exponent 10 is raised to get to 200. And we can check this by doing 10 raised to the answer we got. So the output of a log entered as an input should give us our original value, 200. So the log of 200 gives us 2.3 and change. 10 to the 2.3 and change gives us back 200. These are inverse functions. And the same with ln. ln of, we'll do 200. It's going to be a larger number, obviously. We get 5.298. In this case, just to check our work, we do second ln and raise it to that power, and we get back 200. Why is this answer larger than the value for the log of 200? We're taking a smaller number and multiplying it repeatedly to get to the same value as we did with the 10. So it's going to take 3 multiplied by itself a few more times to get to 200. All right, simplify without a calculator. What we're basically looking at here is considering it like an exponent. What we're saying is 10 to what power equals 1,000. And the answer with 3 zeros, the answer is going to be 3, 10 to the third. Likewise, with ln of e to the 2, you can think of this as log base e of e to the 2. So we're saying, we do the loop thing, e to what power gives us the argument e squared. What we're saying there is e to the x equals e to the 2. The answer is 2. We can equate the exponents. This one's a little trickier, but not too bad if we write it as a fraction. 1 over 100. This is the log base 10. So we're saying 10 to what power equals 1 over 100. And remember, think negative if you see a fraction. So to get 10 to equal 100, it's 2. To get 10 to be 1 over 100, it'll be a negative 2. And so our answer here is negative 2. And likewise with ln, this is going to be a fraction, so take a guess at what you think this would be. You can hit pause and then see if you get it right. And the answer is negative 3. All right, why don't you give this one a try? Remember, it's a fraction. And 10 to what power is, we could write this as 10,000 to the negative 1 if we wanted to, which is 10 to the 4th to the negative 1, which is 10 to the negative 4. And if you got negative 4, you were correct. Give this one a try. It's that number e you're not familiar with, but it works just like any other number. Try this one. All right. The answer here is going to be 1/2. E to what power equals, and you have to remember, square root is 1 over 2. Remember, the roots are the denominator. So we can equate the x and the half. The answer is 1/2. This one's kind of a tricky one, but when you see it, you'll recognize how to get your answer. If we wanted to rewrite this as a logarithm, or if we wanted to take the logarithm of both sides so that we could get the exponent by itself, we could rewrite this as the log of the base, in this case it's a, raised to the something that will be our exponent, that's this stuff here, log base a of x, equals something we don't know. And the thing we don't know, we can call it anything. We'll just call it box. So what we're saying is, we want that thing. What will it equal? And in this case, equate. If the log base a of what we need equals the log base a of x, then the answer is x. And what's happening is, we're undoing our exponent with a logarithm. The format is really kind of strange looking, but it gets us back our argument. So raising a log to the same base is going to give us our argument back. Let's try another one. If we wanted to look at this one, we could see that the log of this base of something equals log base 2 of 8. If we equate these, we see it should be an 8. Take a guess at what you think 10 raised to the log base 10 of 100 would equal. Hit pause. And the answer is 100. We can go ahead and just prove that to ourselves. 10 raised to the log of 100 equals 100. And that's been the case here. So try this one, hit pause. The answer is 15. I'm not a big fan of this type of equation, but it helps illustrate how log and exponent work to undo each other. How about this one? Log base 10, because it's not written, of 10 of the fourth root of 10 cubed. Well, a good way to think about this is to rewrite as a single exponent, 3/4. And what we're saying here is this is a base 10. So if we wanted to rewrite as an exponential, we'd see that with the loop thing, we'd have 10 raised to some power equals 10 to the 3/4. Well, if you equate these, you see it's 3/4. And we can test that on the calculator as well. Log of 10 raised .75. Okay. This is going to be a little bit tricky. Here we're saying 10 raised to what power? Gives us a negative value. The answer is no real solution exists for this. Now, likewise, to find the log of a negative value, your answer will be no real solution or no solution. You'll discover ways around that later. So whenever you take the log of a value, it must be the input or the domain for all log values has to be positive, just like the output for all bases. And last, we're going to look at solving an equation with our new tool here, the logarithm to undo. So let's go through this. We want to undo operations, kind of like when we did the trig stuff. We're going to divide first, because there is no addition to undo outside of parentheses. We get the log, common log, of 2x plus 1 equals 2. And then what we're saying here is 10 to what power? 10 to the 2 equals our argument, 2x plus 1. And then it turns into a pretty straightforward algebra problem. Well, we know 10 squared is just 100. We'll subtract 1 and divide by 2. We'll get x equals 99 over 2. So when we plug in the calculator, hopefully we'll get our answer here. 15 log of 2 times 99 divided by 2. I guess we could have done that in our head. That'll be our 99 plus 1. Should give us 30, and it does. All right, so we want to always check our answers, make sure we're good. The domain being positive, positive values, 99 over 2 qualifies. We're going to do a few of these, so get ready. Undo the plus 3 with minus 3. ln of x minus 4 equals 3. We're saying e to the 3 equals x minus 4. And we'll just add 4 to that. X equals e cubed plus 4. And I think we'll just leave it like that. Obviously, that's a calculator problem. The answer will be positive, however. So we're good on that. Do another one. Go ahead and get started on this one. See if you can get through it all, and then see what your answer ends up. Hit pause. All right, back to a divide by. Look at the log base 6 of x plus 5 will equal 2. And now what we're saying is 6 to the 2 equals our argument, x plus 5. Well, that's 36. Subtract the 5. And we get 31. And that is a positive value. 31 plus 5 is 36. If you plug it back in, you find out that the 9 times log base 6 of, in this case, 31 plus 5 equals 18. And sure enough, this equals the log base 6 of 36, meaning 6 to what power is 36? And that's a 2, and that equals 18. Again, it was a positive number, so we're good. Go ahead and try this one. See how far you get, and then hit play. All right, we're going to undo the addition and subtraction first. Then we'll undo multiplication with division. So 4 to the 2 equals 6x minus 2. 16, add 2, divide by 6. And that is a positive value. Make sure it works in our solution here. 18 minus 2 is positive. We're good. Go ahead and try these on your own, see how they work, and then we'll meet you in class.